Let's perform the integral test. So the integral test, what is integral test? So in the previous video, we talked about it. I can give you a brief summary really quick. So we are trying to compare the series to a definite integral. So the series is less than the definite integral because the area is trapped under the curve of the function. So that's why the series is less than the integral. So in integral test, you have to perform the integration. So, and then the result, there are two cases. If the result is equals to a real number, then the series is convergent. So real numbers treat that as a 10, a 25. So 10 and 25, they are real numbers. So that means the sum is slightly less than that. So which is a converge. Otherwise, if the integral is equals to an infinity, so that means the area is super big. So we have the series slightly less than infinity. So that means the series is divergent. All right, so we have to do these 5 problems, and then one other thing that you have to know is the function must be continuous, positive, and decreasing. All right, so let's take a look at the first one. The first one, we have n raised to the negative 3 power, so that is the same as 1 divided by n to the third, right? Okay, let's do that. First problem, so we have number 1. We have a series, n goes from 1 to infinity, n to the negative 3. So that is the same thing as f of x is equals to x to the negative 3, which is the same thing as f of x is equals to 1 divided by x to the third. So this is a continuous, positive, and then decreasing function from 1 to infinity, right? So as x increases, the y value decreases. So that means the integral test applies, and then you have to perform these integrations from 1 to infinity, x to the negative 3 dx. So this is a simple power rule, and then since there is an infinity, you have to do an improper integral. So that is equals to limit. By the way, this limit, writing this limit is required because you are doing improper integral. Improper integral. So limit as x approaches to, not x approaches to. Actually, that is a t approaches to. That is how we do improper. So this is from 1 to t, and then x to the negative 3 dx, and then that is equals to limit as t approaches to infinity. You apply a simple power rule, so that is x to the what? X to the negative 2, right? So negative 3 minus 1, sorry, negative 3 plus 1 is equals to negative 2, and then the coefficient, you take the reciprocal of the exponent. So that goes from 1 to t, and then you plug it in, so you have a negative 1 half, right? So you have a negative 1 half, and then you plug in the t, so you have that, you have a infinity square, and then minus minus, so that will be plus, and then you plug in a 1, then you get a 1 over 1. So the first piece is just a 0, right? So because 1 divided by infinity is equals to 0, so you have 0 plus 1 half, that is equals to 1 half. This is a real number, so we say that the area is finite, so finite area, I forgot the E, finite area, so that means the series is convergent. That's how you perform the integral test. Okay, so next problem, we switch color for that. As we move down, you won't see the problem anymore. So now is a good time to take a screenshot so you can capture all 5 problems. So number 2, we have a series, n goes from 1 to infinity, and then we have n divided by n squared plus 1. So I'm going to move up. So this one, what is the function? The function is f of x equals to x divided by x squared plus 1. The denominator is greater than the numerator. So this function must be a decreasing function, right? So it's a decreasing. And then a positive, so that is always above the x-axis. And then a continuous. Why is that a continuous? There is a denominator, x squared plus 1 is never equals to 0. And then every time you plug in a value to the x, you square that, you add 1 to it, so the bottom is always positive. So that means the integral test applies. So that must be from 1 to infinity. And then one other way to prove that this is a decreasing function is you use your graphing calculator to graph it. But the denominator is always greater than the numerator, so this must be a decreasing function. And then we do the improper integral from 1 to infinity, x divided by x squared plus 1 dx. So that is a limit as t approaches to infinity. You have from 1 to t, x divided by x plus 1 and then dx. What kind of technique do you have to use to integrate? You learned that in the past. Integral calculus. Still remember that? That one is a pretty common technique that is called a U-substitution. So you let u equals to x squared plus 1, so du is equals to 2x dx, and then 1 divided by 2x du is equals to dx. So basically we isolate the dx on one side. That means when you replace the dx, what is the dx becomes? So the dx becomes this, so this is dx, right? So now you replace this part to the dx. And then after that, the numerator, the x, can be cancelled. Okay, so let's continue the integration. So we have a limit as t approaches to infinity. So we have what? After you replace the dx with 1 divided by 2x, so you have the x got cancelled. So that becomes a 1. The denominator is u, then you have a 1/2, right? And then this is for du. So since the t is with respect to x, let's don't write the upper limit and lower limit for now. And then you integrate this. So that will be a ln. Limit as t approaches to infinity, and then the integral of 1 divided by x dx. What is this? Is this a power rule? No, that is not. This is ln absolute value of x. So ln absolute value of x. So we have ln absolute value of x. So what is x? X is x squared plus 1, right? Now answer this question for me. Do we need the absolute value? The answer is no, we don't need it, because x squared plus 1 is always positive. You square any number, you add 1 to it, that must be positive. So therefore, we do not need the absolute value. A parenthesis, you do the job for us. And then we miss the 1/2 in front of the ln. That goes from where to where? That goes from 1 to t. And then you do the plug-in fundamental theorem of calculus. So this one is ln. 1/2 ln, you have an infinity square plus 1, so that will be infinity, and then minus 1/2 ln, and then this will be a 1 plus 1, right? 1 square plus 1 equals to 2. What is ln infinity? Ln infinity, this is the graph of ln as x goes to infinity, y goes to infinity. So therefore, this becomes an infinity minus 1/2 ln2, 1/2 ln2. You take the infinity minus that. That means you take a huge number, you subtract a little bit, so that is still at infinity. So therefore, we have an infinite area. So the series is divergent. So that's how you do number 2. And then number 3, we have a sum x n goes from 1 to infinity. We have a 1 divided by n squared plus 4. This is a very interesting problem. I always pick the best problem to discuss with my students. So number 3, we have the sum n goes from 1 to infinity, 1 divided by n squared plus 4. So first of all, here is my function. That is 1 divided by x squared plus 4. So this function is always positive. The denominator is greater than the numerator, and that is decreasing. X squared plus 4 has no discontinuity, so that is continuous from 1 to positive infinity. So therefore, the integral test apply. And then you set up the integral from 1 to infinity, 1 divided by x squared plus 4, and then dx. So this one is equals to limit as t approaches to infinity, 1 to t, 1 divided by x squared plus 4, and then a dx. Okay, and then this one, the reason I picked this problem is because I want you to remind you an integral that you learned from your previous class. So in you just made it to series and sequence. You must have learned this in the past. I will do this in red. So still remember this formula, the integral of 1 divided by x squared minus the square of a constant dx. This one is 1 divided by a times the inverse tangent of x divided by a plus c. You must have learned this in the past. When you study integration techniques, you must have learned this in the past. So this one, the 4, in our case, 4 is equals to 2 squared. So that means a is equals to 2. Now, can you apply the formula for me? So what is that equal to? That equals to limit as t approaches to infinity. Let's integrate that. So the a is equals to 2. So 1 over a is 1 divided by 2. And then inverse tangent x divided by 2, right? And then we don't do the plus c because we are doing a definite integral that goes from 1 to t, and then you plug in the t, plug in the 1 using fundamental theorem of calculus. So you have 1/2 inverse tangent, t will be infinity, right? Divided by 2, and then minus 1/2 inverse tangent, and then 1/2 inverse tangent. That's why I like this problem so much. So infinity divided by 2 is infinity. So infinity divided by 2 is just an infinity. What is inverse tangent of infinity equal to? I want you to think about that. Okay, still remember the graph of inverse tangent. You must have used that from your integral calculus class when you were learning integration technique. So this is the graph of inverse tangent. There are two horizontal asymptotes. One at pi over 2, one at negative pi over 2, and here is inverse tangent. So now, can you answer the first one for me? What is inverse tangent of infinity equal to? So as x goes to infinity, you look all the way to the right. So what is that equal to? That is equals to pi over 2, right? And then what about 1/2? The 1/2, you don't see the 1/2 in here, so it is okay to just leave it like that. So overall, you have pi over 4 minus 1/2 times inverse tangent of 1/2. You don't need to use your calculator because that's all I want to know. This is not equal to infinity, right? So that means we have a finite area. Finite area. So that what does that mean? That means when you add the sum, when you add up the terms from the first term to the very last term, what is the sum approximately equal to? So you have this, right? You have a sum, n goes from 1 to infinity, 1 divided by n squared plus 4, right? So that equals to a1 plus a2, and then plus dot, 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 all the way to the very last term, right? What is the sum equal to? The sum is approximately equals to, so this sum is approximately equals to this. Approximately equals to that, so that is not infinity. The area is finite, so that means this integral is convergent. That's how you perform the integral test. All right, so this is the end of this problem. So let's move on to the next one. The next one, we have n to the third divided by n to the 4 plus 4. Switch color for that. Which one should I use? Let's use a blue. So that the next one is this is a number 3, and then number 4. So number 4 is the sum. N goes from 1 to infinity. N to the third divided by n to the 4 plus 4. And then my function is f of x equals to x to the third divided by x to the 4 plus 4. And then this is a decreasing function because the numerator is always greater than the denominator. All right. And then this is always greater than 0, and then what else? Positive. And then greater than 0, positive, and then continuous, right? Because there is no discontinuity from 1 to infinity. The denominator, you can plug in whatever value you want. Okay, and then we have to perform the definite integral. So one thing that I want to do is I want to prove this. This one is always positive. This one you might be thinking, hey, why is this always positive? I want to prove it. this is positive. I put a question mark right next to it. So before we start the definite integral, allow me to prove that really quick. So first of all, we have to, how do you show that this is positive? How do you show that, oh, actually that is not what I'm trying to do. I want to show that this is a decreasing, always decreasing. So one thing that you can do is you graph it, right? Another thing that you can do is you look at the slope. All right, so let's do the slope. So we have f prime of x. Again, I want to show that this is decreasing. So f prime of x, that is equals to, what rule do we have to use? This one is a rational function that we have to apply the quotient rule. So the quotient rule is gf prime minus fg prime divided by g squared, right? So first I have square the denominator, x to the 4 plus 4 square, and then we put this up, x to the 4 plus 4, not 2, 4, x to the 4 plus 4, and then the derivative of f, which is a 3x squared minus, for the quotient rule, and then x to the third derivative of the denominator, that is 4x to the third. And then what is that equal to? Open up the top, so that is equal to 12 squared minus x to the 6 divided by x to the 4 plus 4 square. And then how do you show that this is a decreasing function? Decreasing function, that means you have to show that the slope is negative. So when slope is negative, the function is decreasing, right? So you have to show that this is negative. That means that can the denominator be negative? The answer is no, because there is a square. When you square something, you are making that always positive. That means our only chance is we have to make the numerator negative. So that will be 12 minus x to the 4th less than 0. So that is 12 less than x to the 4th. And then we take the 4th root on both sides. So this is equals to 1.86. X must be greater than 1.86. And then the f is decreasing. We say that f is decreasing when x is greater than 1.86. All right, so when x is greater than 1.86, but the n has to start as an integer. So since we have to start as an integer, what has to start an integer? This n from infinity, that has to start as an integer. So this one, instead of 6, we round this to a 2. So that's why we start at 2. That changes the improper integral. So this improper integral is now go from 2 to infinity. We have x to the third divided by x to the 4 plus 4 dx. So set up the improper integral. T goes to infinity. We have 2 to t, and then x to the third divided by x to the 4 plus 4 dx. This is a U-substitution. We let u be the denominator, and then du is equals to 4x to the third dx, and then we isolate the dx on one side. We have 1 divided by 4x to the third du, and then here is how we do the substitution. We replace the dx with this. So after the replacement is done, the x to the third will be cancelled, and then we keep on going. We have limit as t goes to infinity. So the x is cancelled, then we have 1 over u, and then after the x to the third is cancelled, and then after that is cancelled, you only have 1 over 4 du. All right, so because that is in terms of u, so that is take the integral of that. The reason I don't put the lower limit and upper limit is because the 2 and the t, they are with respect to x. All right, so we don't put the 2 and the t in there. So this one we have 1 over 4, and then ln, the absolute value of u, right? So since u is equals to x to the 4 plus 4, that is always positive, it is not necessary to use absolute value. So that goes from 2 to t. And then you plug in the t, you plug in the 2, then you have 1 over 4 ln, so infinity to the 4th plus 4, still infinity, minus 1 over 4 ln. 2 to the 4th power is 16. 16 plus 4 is equals to 20. So that will be an infinity minus that, so which is equals to infinity. Then we have an infinite area. So the area under the curve is infinite. So just like that, we have a curve. The area from 2 to infinity, this is infinity. And then what about the series? The series is right here. You have those rectangles right here, right? So you have those rectangles right here. Since the entire area is infinity and the rectangle, this rectangle, the sum of this little rectangle is slightly less than the infinity. So that means this must be something less than infinity. So that means the area is infinite. What is that means? That means the series is divergent. That's how you perform the integral test. And then we have one more problem left. That is a very good problem too. So let's go ahead and take a look. Number 6. Oh, actually, that is a number 5, right? Not number 6. That is actually a number 5. So we are number 5. We have the sum. N goes from 2 to infinity, and then 1 divided by n times ln n. So the function is f of x equals to 1 divided by x times ln x. What's the problem in here? When the interval goes from 1 to infinity. Is this interval correct? The answer is no, because n starts at 2. So this one we can forget it. How come they don't go from n to infinity? Because ln of 1 is equals to 0. They don't want to have a 0 in the denominator. So that's why they cannot start at 1. Okay, now tell me, how do you prove that this function is decreasing? So from 2 to infinity, you can plug in whatever you want, right? You can plug in 2, 3, 4, 5, 6. I don't really care. So that means the function is continuous. And then 2 is always positive. ln 2 or above is also positive. So that means the function is always positive. How do you prove that the function is decreasing? To prove decreasing, you have to find the slope. So f prime of x, you have to perform a quotient rule. So quotient rule is gf prime minus fg prime divided by g squared. So we square the denominator. That will be x squared times ln x, the whole thing square. And then g is this. The derivative of 1 is equals to 0 minus f, and then g, the derivative of the denominator, that is a product rule. Product rule is fg prime plus gf prime. So fg prime, so f is we have x times ln x, right? So that will be x times 1 divided by x. That is the derivative of ln, and then plus gf prime, so that will be ln x times 1. And then overall, what do you have? So f prime of x, so the first term has a 0, so that will be and then you distribute this, right? So that will be a negative 1 minus ln x divided by x squared, and then ln x squared. This one has to be negative in order to prove that the function is decreasing. The denominator, there are squares, so that is always positive. That means we have to make the numerator negative. Negative 1 minus ln x must be negative. And then you have to solve for x. So we have ln x less than 1. And then we multiply both sides by negative 1. Then we have to reverse the inequality symbol. And then what is this equals to? So that is raised to the, that is a base e, right? So x is greater than e to the negative 1. So which is around 0.368. So x has to be greater than 0.368, but f is undefined when x is equals to 1. So that's why the integral has to start at x equals to x equals to 2. So therefore, the improper integral goes from 2 to infinity. We have 1 divided by x times ln x dx. and then we set up the improper integral. T goes to infinity from 2 to t, and then we have 1 divided by x times ln x dx. The u substitution is u equals to ln x, and then du is 1 divided by x dx, and then isolate the dx on one side, so this will be x times du, and then we do a little replacement, so this dx will be replaced with the x times du. As a result, the x will be cancelled. All right, and then we have limit as t approaches to infinity. We don't write the upper and lower limit. We have 1 divided by u, and then du. That's it. 1 divided by u du. So that is equals to ln, right? Ln absolute value. But do we need the absolute value? Yes, we do. We need the absolute value because ln x we cannot guarantee that it's always positive. So this one we put the t back, and the limit that goes from 2 to t, and then we do the plug-in. So ln of ln t, which is infinity, and then minus ln of ln2. So what do we have? We have infinity minus ln of ln2, right? So that is just equals to infinity. That means the area is infinite. What is infinite area? So let's draw a graph real quick. So this is the graph, and then we have a function, and then the area from 2 to infinity, this area is infinite. So that means the area under the curve is infinity. And then what about the series? So here is the series. The series is right here. So these little rectangles, they are my series, a1 plus a2 plus a3, so on and so forth. So the series, the sum is always less than the area obtained from the integral. So that means if this is infinity, then this is something a little bit less than infinity. So this one will be just a smaller infinity. So therefore, the area is infinite. So when the area is infinite, we say that this series is divergent. So that's how we perform the integral test on this. So that is also the end of this video. In the next video, I will introduce p-series. If you think my instruction is helpful, let me know in the comment section below. Please subscribe, share, and like the video. Appreciate your help. See you in the next one. Signing out for now.